We shall see the next problem on belt drives. A layout of leather belt drive transmitting a power of 15 kilowatt is shown in figure. The center distance between the pulleys is twice the diameter of the big pulley. So here they have given the figure. The center distance between the pulleys is twice the diameter of bigger pulley. So we shall consider the diameter of bigger pulley as capital D and smaller pulley as small d. Then the center distance will be twice the diameter of bigger pulley. So we have taken it as 2d. The belt should operate at velocity of 20 meter per second and stress in the belt should not exceed 2.25 MPa. The density of the leather belt is 0.95 gram per cc and the coefficient of friction is 0.35. The thickness of the belt is 5 mm. Calculate first one, diameter of the pulleys, length and width of belt and belt tensions. So they are asking us to find the diameter of both the pulleys. We have to find the diameter of both the pulleys. We have to find the center distance. So we have to find the length and width of belt. We have to find the length and width of the belt and belt tensions T1, T2. So we shall write the data. Power 15 kilowatt. Center distance C is 2d. Velocity 20 meter per second. And stress in the belt should not exceed 2.25 MPa. The density of the leather belt is 0.95 gram per cc. Density rho and the coefficient of friction mu is equal to 0.35. The thickness of the belt is 5 mm. Thickness T they have given as 5 mm. Calculate diameter of the pulleys. We have to find D, length, belt tensions. So first they have given the velocity, so we shall make use of that. They have given the speed of both the pulleys. So NS and NL. NS is speed of smaller pulley and NL is speed of larger pulley. So it is 1440 RPM and this is 480 RPM. So we shall take V is equal to pi dn by 60. So D we have taken smaller pulley. Usually the smaller pulley will be the driver in maximum cases. So if they are not given, we shall take smaller pulley as driver. So V is 20 meter per second. Pi D N is smaller 1440 by 60. So D we will get from this 265.26 mm. So we shall consider from standard table. There is one table in page number 313. Page number 313. There is a table 14.13b. So nominal diameter of cast iron and mild steel pulleys. So here in problem we have got 265. Here there is 250 and 280. So we shall take 280. 280 mm from table 14.13b. page number 313. So we have found out the diameter. Now we shall take velocity ratio. Ns by Nl is equal to d by d. So this is the velocity ratio. Ns by Nl is equal to capital D by small d. So they are given the diameters 1440 by 480 is equal to d by 280. So d we will get 840. So since we found out the capital D, we can find the center distance. C is equal to 2D, 2 into 840, 1680. So they are asking to calculate the diameter of pulleys. We have found out the diameter. Next we shall go to length and width of the belt. So from data handbook there is formula for length. So in page number 289 there is 290 page number, there is length of open belt and length of cross belt. We shall take the length of open belt. We shall take this formula because this formula it has theta angle. We are unaware of the angle, so we shall take this formula. So this is from equation 14.2b, page number 290. Two into 1680 plus pi by 2 into 840 plus d. Plus d minus d. So the length of belt which we'll get from this formula is 5166 mm. 5166 mm. So we shall keep this in meters. 5.166 meters. Next we'll find the velocity, because here the velocity, by using velocity we have found out the diameter, but in the question they have given the thickness also. So we shall consider the thickness. V is equal to pi dn by 60. They are given thickness as 5 mm. .56. So here we had found out the velocity. They had given velocity in the question, but we have considered the diameter and thickness, and we have found out the actual velocity. So it is 21.56 meter per second. Next, we shall move on to find the. We have found out length. We shall find the value of width by using the formula power. They have given the formula for power. So here we shall take the formula BTV by 1000 into, we shall take this formula 14.5A, page number 291. Equation 14.5A, page number 291. So in question they are given the value of power as 15 kilowatts. So before proceeding, we have to find the value of theta. Here we shall find the value of theta. Theta, yes, we shall take it because we have considered a smaller pulley as the driver, and from data handbook, the angle for smaller pulleys, here they are given theta, yes. We shall take pi minus d by c. So this is equation 14.1A, page number 289. D is 840 minus 280 by 1680. 2.81 radians. This is the formula for radians. So the value of theta we will get directly in radians. Now we shall proceed with the formula power here. So we shall take the value of theta here. So from this formula, if we solve, we'll get the value of b. Here width we are going to find by using this formula. So the value of width which we will get is 123 mm. 123 mm. So we have a standard table for width. We shall take standard value from that. Table 14.9A, page number 311. This is the standard table for width. We have got 123 mm, but here there is 125 mm. We shall take it as 125 mm. So this is from table 14.9a, page number 311. Now we shall find the value of belt tensions. They have asked us to find the value of belt tension. So we shall find the value of belt tensions also. So for belt tensions, we shall take this formula. Before taking that formula, we shall take the formula for power. P is equal to T1 minus T2 into V by 1000. We shall take this. So the value of power is 15 kilowatt. T1 minus T2 into V. V is 21.56. So by the value of T1 minus T2 is 695. 695.73 newtons. This is the value of T1 minus T2. So we shall go to data handbook and we shall consider the value of T1 by T2 minus, we shall take this formula because we need to find the centrifugal tension also. T1 minus Tc by T2 minus Tc is equal to